So we got adding and subtracting with mixed units. So we've done mixed numbers before, and the truth is, if we can understand, if we can go back to, I think it was module 1 or 2, and just understand how to either carry or borrow, it's the same idea, but now we're not carrying tens or borrowing just tens. Sometimes we carry and borrow 12s or 3s or something like that. That's it. So yeah, remember, math is what we want. And so just like last time how we took a 1 and then made it something divided by itself, today we're going to be doing the same thing. We're going to take something. For example, what we can do is we can take 15 inches, okay? But instead of showing it as 15 inches, I mean, 15 inches is fine, but mathematically in today's lesson, what we would maybe want to do is change this into 12 inches and then maybe 3 other inches, okay? Because if I were to add these two together, then I still have the 15 inches. I haven't changed the length. All I've done is changed that I've split it up into 2 separate parts, one 12 inches, one 3 inches. Now, why would we do this? It's because maybe we want those 12 inches to be 1 foot instead. And so we can make that 1 foot and 3 inches. It's exactly the same. All 3 of these are the same. But again, it's about what we want, right? So in the future, I have the arrows going this way, but in actuality, what may end up happening is we may go in this direction as well, okay? So instead of having a foot, maybe we would like to see that as 12 inches, and then we can combine that with 3 other inches and then make it 15 inches. It depends on what we want. This is the concept of borrowing or carrying, just like we've seen before. So in the past, we have looked at carrying and borrowing. Addition is carrying, is this idea of carrying, right? So for example, if we were to look at this first one in the top left, 297 plus 65, we would start in the ones place value, would say 7 plus 5 is 12. Okay, but we have by place value, we have 2 ones, but then 1 10 as well. So what we did in the past, we took that 1 10 and we carried it over into the tens place value. Now, if I were to add these, I'd have 1 plus 9, which is 10, plus 6, which is 16. Now, that's from the addition. This 16 is from the addition of 1 plus 9 plus 6. But again, now we have 6 tens, but an extra 100, which then we would carry over into the next place value, the hundreds. Then 1 plus 2 is 3. So that's how we've done addition in the past. But again, these were all carried by tens because these are all base 10 values. 1 is a base 10. 10 is, of course, a base 10. And then 100 is 10 times 10. So it's a base 10. Now we're going to apply the same idea here to this next example. You got 2 feet 10 inches and 3 feet 9 inches. Now we usually just add these directly, but we start with the smallest units in case we can carry them over into the next units. Okay, so for example, if I did 10 inches plus 9 inches, I would have 19 inches. And then 2 feet plus 3 feet, you could say is 5 feet. Okay, now 5 feet 19 inches, it may serve a purpose for you if you're out in the real world. You say 5 feet 19 inches, and that's okay. But in a math class like this one, especially where our objective is being able to add these, mathematically we want this in the smallest terms. So what we would do here is we would look and would say, we can't forget, especially with inches and feet, that 12 inches is 1 foot. Okay, so we can write this in, would say 12 inches equals 1 foot. Now, again, if you don't have that memorized, you can always refer back to the conversion factor chart. But what this means is this 19 inches has a 1 foot somewhere in here, which then we can convert into this foot. So what we would do is we would take those 19 inches and we would take away, it's like we're taking away 12 inches, but that allows us to add an extra foot. Okay, so I take away these 12 inches, but that allows me to give those 12 inches into this 1 foot. And then if I wanted this simplified, which I do, then I would have 19 inches minus 12 inches would be 7 inches. And 5 feet plus 1 feet would be 6 feet. and that would be considered simplified. Now, overall, the lengths are the same. 5 feet 19 inches is exactly the same as 6 feet 7 inches. But again, the 6 feet 7 inches is what we would consider simplified. So that's carrying, and that's how we do this with mixed units like feet and inches. We will probably end up doing this with like weight and volume as well. But if we do, again, we'll refer back to the conversion factors that we know. Now that's if you're adding. If you add, then you carry. Again, we used to carry by tens. Now this was like carrying by 12s. So we carried a 12 over into the feet into what would be considered the next place value. Now we got 6 feet 7 inches. Subtraction is like borrowing. So if you need to take something from the next place value, then you can. For example, now it says addition, but there should be subtraction right there. So again, you start in the ones place value. Now we'd start with 2 minus 4, but 4 is too big to take away from the 2. So that means we would borrow a 10. Okay, so that makes us 12, and then we take away one of these 10s, and that becomes now a 0 right there, right? Now, again, we look at this and we're like, well, what happened to the 1 right there? It's right here. It's right there. Okay, so we have 200 and the 12, right? Just like we had before, 212. But I've given 10 ones into the ones place value to give to the 2 to make it now 12. So then we'd say 12 minus 4, which is 8. And then again, then you've got 0 minus 6. Okay, well, 6 is too big to take away from 0. So again, we'd look to the next place value. We'd say, I'm going to borrow one of these hundreds and give it to the 10s. That'd be 10 tens right there. And so the 2 minus 1 is now 100. So then in the tens place value, you do 10 minus 6, which is 4. And then you drop the 1 there from the hundreds. Okay, so that's borrowing. But again, in the past when we did this, it was only borrowing tens. But like we saw with the carrying, where we carried a 12 inches over into 1 foot, we're not going to be carrying just tens anymore like with feet and inches. You may have to borrow an extra 12 inches somewhere in here in order to make this one work too. So if we were to look at this one then, so let's compare these. Okay, once again, subtraction, and if you'd like to see the extra subtraction right here with the inches, because that's what we really are doing, kind of like we do with the place values. You subtract the ones, and then the tens, and then the hundreds. Now we're subtracting the inches, and then we're subtracting the feet. Okay, so 9 is too big to take away from the 4. So again, we look at this 4, it's with the 5 feet. So this is 5 feet 4 inches. So when I borrow for the 4 inches, I have to borrow from the 5 feet. I can't borrow from the 3 feet into the 4 inches. Okay, and of course we wouldn't borrow for the 9 inches because that's what we're taking away. And if we made that bigger, then it just further complicates things. So once again, I usually would ignore the feet like I would with the place values over here, but I need these 5 feet. I need one of them. I need one of those 5 feet in order to add 12 inches to the 4 inches. So this is the way that I would show this. See if we can make this look pretty. Okay, so I have 5 feet. I'm going to take away 1 foot. Okay, now this is going to give me a new value because I took away one of my feet there. I now have 4 feet, but once again, that 1 foot I'm going to convert into the inches. So I'm borrowing those 12 inches in with the 4 inches. So 4 plus the 12 inches would now give me 16 inches. Okay. Now that I have those 16 inches, now I should be able to subtract the 9 inches like this. So this is the problem we started with, but now that I've converted 1 foot into the 12 inches, I'm borrowing those 12 inches from the 5 feet, just like we would usually. I can subtract these inches. So I will. So first up in inches, 16 minus 9 should be 7 inches there. 4 feet minus 3 feet now is 1 foot. Okay, so be very careful on this because, again, this kind of stuff opens ourselves to mistakes here, especially with the subtraction stuff, with the borrowing. because we're so used to borrowing by tens that we start saying, well, 5 feet, it would give 10 inches, and then it's 14 inches, but that's wrong because it's 12 inches in 1 foot. So this is what we would call non-base 10 borrowing, which I want to say they used to do it in like Greece or Rome or something like that because they had a base, geez, it seems like it was a base 7 system or something like that, but what do we care? So here's the conversion factor. So the two examples that we just saw on that last slide were all length with feet and inches. Of course, they may do like yards, feet, and inches, or they may do miles and feet or something like that. Or they may do weight with tons or ounces or pounds, whatever. And then capacity or volume. So remember, with addition, if you have too much of one unit, then you must convert it to the next unit up, just like we saw in those last two examples. If we do subtraction, once again, you'll just usually have to take one. You don't usually have to take like 2 out of something or 3. It's just always 1 in order to make the smaller units bigger so that you may now subtract a value. Now, you don't always have to borrow, right? So, you know, if you had 11 inches like this, and you were just minusing 3 inches, no borrowing is necessary because taking away 3 inches can happen with 11 inches. But it would be problematic if you were to make this instead of 11 inches, maybe you made it 1 inch instead. Okay, that now is problematic. Now you've got to look to your feet in order to do some borrowing. We should never see negative values in these, whether it's addition or subtraction, because we never look at length, weight, or capacity in terms of negatives. So if you find that you've given yourself a negative in your answers, it shouldn't be there. Yeah. All right, so this one's a capacity one. We got 13 pounds, 10 ounces. Oh, we're going to convert this into ounces? Oh, okay, so it's a mixed unit, right? So we got a mixed unit of pounds and ounces.
Hold on, did you do anything with that?
So we're not adding here, right? But what we would like is, we don't want the pounds. We got the ounces, and that's good. We'll keep those ounces, and we'll add those in. But what we need to do is take these 13 pounds and convert these into ounces. So we have a conversion factor there in the bottom right. 1 pound is 16 ounces. So I'm going to take these 13 pounds, and I'm going to do what we've already been doing. So I'm going to use the dimensional analysis method in order to change these pounds into ounces. So I'm going to make this over 1. Again, we've given ourselves the appropriate conversion factor here. And so I'm going to multiply this. Once again, I need the pounds to go away. That's LBS. And what I'd like to do is convert these into ounces, which the conversion factor gives us. So now that I've got my labels arranged, which allows me to cancel out the pounds, then we know from the conversion factor, 1 pound is 16 ounces. So again, put the labels in is what I recommend, and then apply the appropriate values based on where you put the labels from the conversion factor. So with this, then this will convert, this is not our answer, by the way. This is only going to give or convert the 13 pounds into ounces. So, I get a calculator here. 13 times the 16 there. I don't care about 1 times 1 in the denominator, but this is going to be 208 ounces. Okay, so if we go back, we started with 13 pounds, 10 ounces. But the 13 pounds we now know is 208 ounces. So before we had 13 pounds and also 10 ounces. But now we have 208 pounds and 10 ounces, which means we're going to add those together. When we do add these together, we end up with 218 ounces. And that's it. Now, really what this is it's kind of like looking at, looking at a mixed number, but the conversion factor tells us part of the mixed number. So for example, if you were to have converted 13, that was the 13 pounds, then you had 10 ounces, but that would have been out of 16 ounces because 1 pound, every pound, and we got 13 pounds already, right? But we know every 1 pound is 16 ounces. So there were 16 of these 13s, so that'd be like cycle method, multiply, and then we added the 10. Cycle method is the same idea, but again, the conversion factor will tell you what that denominator is. The mixed units up here kind of tells you the whole number and then the numerator. Now, just think about this. If they had said change this these 13 pounds, 10 ounces into a decimal, then what we would have done, we would have kept the 13 pounds. I know it's not asking this, but if it had asked for pounds, it would have been 13 point something. Now, how do I know it's 13? Because you start with 13 pounds, and then the 10 ounces is the partial units right there. Now, if that were the case, then you'd still use 10 ounces. You can use the conversion factor down here in order to get the division, which then you would change into a decimal. Seems like it's 0.625, but I also don't care. So, okay, so this one we're going to convert up, right? So we have definitely more than 1 foot right here. We have 119 inches. We're going to convert this into feet and inches. Try this one out, though. We got the conversion factors for length here. Try this one out, then we'll go over it. Okay, so we got 119 inches. What I'm going to do is I'm just going to convert this into feet altogether, which means I would take that 119 inches and make it over 1. So I'm going to use dimensional analysis here. So it says we want feet and inches. So I'm looking for the feet to inches conversion factor right here. Okay, so I'm going to multiply this by the conversion factor. So where the inches are in the numerator, I'm going to need those in the denominator. And that means this would, and it should, convert this into feet directly. So we have inches on the top for the first fraction, inches on the bottom for the second fraction, which will cancel those out. The conversion factor that says that it's 12 inches for 1 foot or 1 foot for 12 inches. I know that says feet, but I don't care. So when we do this, we will now have some number of feet as a fraction because the multiplication, 119 times 1 is 119. And in the denominator, 1 times 12 is 12. Okay, so in my calculator, of course, when I get 119 over 12, I could, with the TI-30 XS multi-view, I can push second, and then I can push the N over D button. Nope, not the N over D button. It's the button just to the right of that. It says times 10 to the power of n. That's called scientific notation button. And just above it, you will see N over D, arrow, and then it has U, N over D. So that's the part that we want to see that says you can change it from a fraction into a mixed number or a mixed number into a fraction, improper or proper, doesn't matter. But this one, since it's an improper fraction, it should change this into a mixed number, which when I did it, it gave me 9 feet. 9 feet. Well, I apologize. The mixed number then was 9 and 11/12. Now again, why is this important? It's because the 9 is the number of feet, and then the numerator, 11, is the number of inches. Why is it the number of inches? Because inches are in twelfths. Okay, so the denominator kind of told us that. Now, if we didn't know that, what we would need to do is we would actually have to use probably long division in order to do this. Long division is going to help us to make this determination without using a calculator in order to make this conversion. So let's do that. It would have been 119 divided by 12. Okay, now again, what happens here is the quotient is going to give me the number of feet, which is what we want, and then the remainder, whenever I get there, will be the number of inches. I'll show the long division then. So 12 does not go into 1. It does not go into 11, but it does go into 119. You guessed it, 9 feet, 9 times. 9 times 12, though, would be 108. And when you subtract this, you're going to get 11, right? So I put those in the wrong place. It's the remainders right here. Okay, but the remainder is how many inches you would then have. 9 feet and 11 inches, which is the same thing that we had right here. And now we've seen the answer in 2 different methods. So we're going to convert 9.7 yards into yards, feet, and inches. We'll do this one together. So 9.75 yards. And we want this in 3 different types of units. We got yards, and we got feet, and we're going to have inches. So I'll just I'm putting these down here and separating them so I can just kind of insert my answers. However, with this, the thing that I don't have to worry about is yards. It tells me in the number, the original number, how many yards, full yards there are. There are 9 full yards. So I'm going to just slip that in right now as yards. That means all I'm doing is looking to convert this 0.75 yards. Okay, because feet and inches are partial yards. Now, again, that may take some intuition and some experience to know that feet and inches are partial yards because they're smaller. But perhaps you knew that already. Okay, but 9 full yards was already given to us in the problem. So what I'm going to do is I'm going to take that 0.75, that's yards. Okay, we'll make it over 1. And I'm going to convert my yards into the next biggest unit of the 3, which would be feet. And we do have a yard to feet comparison right here with this conversion factor. So I'm going to multiply this. Of course, I'm going to put the yards on the bottom so that they will cancel out, and that will then change this into feet. 1 yard is 3 feet. So when I multiply this, I can now get rid of the yards. Yep, so multiplying these, it does give us now feet because we canceled out the yards, but now it is 2.25 feet. So before we start looking into inches first, what we have here is a full number of feet, 2 full feet, and then some partial feet, 0.25 feet. The two full feet is how many full feet that I'm going to put into my answer. What we need in these values, except maybe the smallest one, for the bigger ones like feet and yards, we're going to put as many full units as we can. So I have 9 full yards, 2 full feet. Now I've got to take the partial number of feet, which is showing as 0.25 feet, and I need to change that number of feet now into inches. So we will do that. 0.25 feet. Again, with dimensional analysis, we'll make this over 1. We will then convert. We have a conversion factor from 1 foot for 12 inches. So again, I'm going to put the feet on the bottom, inches on the top. Again, the reason why the feet there are on the bottom is so that I can cancel out the feet, and then I'm left with just inches. 1 foot is 12 inches, and so when I multiply these, I should know how many inches there are. Yep, 3 inches. Now, if it's possible you could have a decimal with those number of inches. This one doesn't, and that's okay too. But just expect perhaps on the assignment you may see that there are partial number of inches. Keep that decimal because that's the smallest units we have. This one did not though, so I'm just going to put those 3 full inches in there. But again, for the smallest units, do expect that it may be possible to have decimal values here, which is okay. All right, now we get to the addition part. Now I've already done 1. I know this one has 3 numbers, but try this one out. And if you make mistakes, that's good. We can learn from those mistakes, and then we can fix them. Okay, but try this one out, then we'll go over it. All right, now what I like to do is I like to stack these and then add them. In fact, I like to do it all at once, so that's what I will do. I'm going to take the first one. That was 24 feet, and we had 3 inches. Okay, and then it says you're going to take 20 feet and 9 inches. And then you're going to take 21 feet and 7 inches, and we're going to add all these together. Now, again, I like to look at these separately like this, too. So that's why I kind of like to rewrite them and give myself some space to work with if I need it. Now, again, you always start with the smallest number or the smallest units, which is kind of like starting with the smallest place value. 3 plus 9 plus 7 should be 19 inches. Now, just that part right there, I know that I have too many inches. Well, I don't have too many inches. I just have more inches than is in 1 foot right here, okay? So that means, even if I wanted to right now, I could. But before I do that, I would actually like to do the other addition for the feet, and then we can work from there. So for the feet, I'd have 4 plus 0 plus 1, which is 5. So that's 5 there.
16.
Nothing to carry. 2 plus 2 plus 2 is 6. So that's right now it's 65 feet, 19 inches. This is a good answer. Like, this is correct. It's true. It's just not fully simplified, which is why on an exam you couldn't get full credit on this. So just like we've seen before, with the carrying, I'm going to take this conversion factor, which says I can take those 19 inches, I can take 12 of them out, and convert that into 1 foot. What I have in green right here is exactly the same. These, in fact, I'll label them. The 1 foot and the 12 inches are the same. So if I take away 12 inches here, I can add a foot here. Again, it's just the same concept as borrowing. So 19 minus 12 would be 7 inches. 65 now feet plus the 1 foot is 66 feet. And I would just check in the end, make sure that there aren't still more inches, especially since we added 3 numbers there. I suppose it can happen, but this one it didn't. That's our final answer. That's it. Yeah, there'll be some word problems on the assignment too. So a set of triplets have the following birth weights. The first weighed 3 pounds 6 ounces. The second weighed 3 pounds 5 ounces, and the third weighed 4 pounds 7 ounces. What was their total birth weight in pounds and ounces? So just by reading that question right there, we're looking for a total, and so that means we're going to have to add those 3 together. Yep. So where the last problem was with feet and inches, feet and inches, now we are looking at pounds and ounces. But the conversion factor, of course, here is different. Try this one out, then we'll go over it. Triplets, right? We got 3 babies here. We got the first one, which was at 3 pounds 6 ounces. We got the second at 3 pounds 5 ounces. Now I'm lining these up like this on purpose. Usually I'd rewrite them and kind of give myself some space, but pounds and ounces is long words, and I don't want to write them that many times. So on this one, we're going to add these together. Boom. Okay, now again, I'm going to add them separately, so I am showing 2 different equation lines here at the bottom, since we're stacking and adding these. What I will have in the end of this first one is ounces. Okay, now ounces, how do we know the ounces are smaller? Because it takes a lot of them to create one of something else, particularly pounds in this case. And when we add them, 6 plus 5 plus 7, we get 18 ounces. And then we would have some number of pounds here, which is 3 plus 3 plus 4, which is 10 pounds. Now again, 10 pounds, 18 ounces, that is good. If you want to just use yourself 10 pounds, 18 ounces. But in a math class, we need to simplify that. And since we have more ounces, we have enough ounces to make an extra pound, then we will. So to do that, we're going to use this conversion factor, which says 16 of those 18 ounces we can use or convert into 1 pound. Okay, so let's start with the ounces first. 18 minus 16 would leave me with 2 ounces. And again, that's because we converted those 16 ounces into an extra pound. 10 plus 1 is going to be 11 pounds. And that's it. So again, I would just check the ounces again just to make sure. Can I convert 2 ounces into an extra pound? Of course not. It's too low. So we have to keep it this way. And that's it. So you're now combining 2 different flavors of juice. You have 5 quarts, 3 cups of grape juice, and 7 quarts, 3 cups of apple juice. How much juice do you have total if you mix the flavors together in quarts and cups? So do you have enough quarts to make gallons? You do in this one, but we're not worried about that. So we're not going to. It says quarts and cups. Let's do this one together. So let's start with the grape juice first. So I'm going to start with the grape juice, which it says you got 5 quarts, 3 cups of the grape juice. Then we're going to add in the, what was that, apple juice, which says it's 7 quarts, 3 cups of the apple juice. So the question asked, how much juice do you have? Well, these are both juices. How much juice you have if you mix them together? So again, we're looking at an addition problem here. So we're going to split this into 2 different addition problems for quarts and cups. So the thing about this, and you may have noticed, let's see, 2 cups Oh, what the crap. Okay, now, it's unusual to say we're going to convert this with one of the units being in between, and we don't have a direct conversion factor for cups to quarts, and that's okay. We'll convert the cups into pints if we need to, but again, if we don't have any full pints, then we'll just keep whatever number of cups that we need. Now, you could use these two conversion factors to just say, well, I know 4 cups is going to make a quart, and that would be fine, but that may not be so obvious to everyone, okay? So let's just do the addition here, and then let's see what we get out of it. So by adding these, of course, I'm going to start with the cups because that's my smaller units, and I'll bring my label down. Labels are important, especially on finals, which are coming up, so I highly suggest using them. That would give me 6 cups. All right, that's nice. And then we're going to have some number of quarts down here at the bottom. 5 plus 7, yep, 12 quarts and 6 cups. Okay, those 6 cups, I'm going to use as many of those cups as I need to convert those 6 cups into however many quarts I can get. If I have leftover cups, then I will keep those cups, okay? All right, so the first thing I'm going to do, like we've seen already, is I'm going to convert those cups into pints. So let's see, and I'm just focused right now on the 6 cups, right? I'm not worried about the 12 quarts, just the 6 cups. I'm going to make that over 1 and use a conversion factor here in order to change the cups to pints. So again, I got cups and pints here. One pint is 2 cups. Well, yeah, very good. Yeah, the cups are going to cancel out. We're going to be left with pints, and then we'd have 6 over 2, which ends up being 3 pints. Now, if you don't know where the 6 over 2 came from, I did 6 times 1 in the numerator, 1 times 2 in the denominator. So 6 divided by 2 gives me 3 full pints right there.
So you do 3.
There's 2 different directions we can go at this point, so I'm going to kind of give myself more space here. And again, all of this is to convert the 12 quarts, 6 cups into quarts and cups. But the 3 pints, let's say that we didn't really understand what to do there. So I'm going to take the 3 pints, and I'm going to convert that into quarts. Okay, because we do have a quarts to pints conversion factor right here. So I would say, well, 3 pints, I'm going to convert those into quarts. And it says 2 pints is 1 quart. So we're doing that specifically to cancel out the pints, which we've done. And this will change this into quarts, some number of fractional quarts. So 3 times 1 is 3 in the numerator. Denominator is 1 times 2 is 2. 3 halves quarts. So I'm going to change this into a mixed number. Well, the decimal, if you were wondering, is 1.5. But I don't really want that 0.5. I think the mixed number is going to help. I'm not saying that you have to use mixed numbers. I'm just using one because I hope it helps us to see what is actually happening. So this would mean that you would have 1 quart, and then you would have half a quart. Okay. So what I'm going to do is I'm going to take this extra quart right here, and I would add it to the original number of quarts that we had. In fact, I'll have to do it over here. That's going to give me 13 quarts. But again, it's like, okay, well, we now only have half a quart, but we have to convert those quarts back into cups. So this, whatever's left over in the quarts is going to be, in the half quart, is however many cups that is how many cups is left over. So it's going to be part of our answer. But again, this means that we've got to go backwards now. So I'm going to multiply those, I'm going to just make that 1 over 2, but again, the quarts would be with the numerator. So I would multiply that. Now I want to get rid of the quarts and change that to pints. And it is 2 pints for 1 quart. And then we would go further backwards. I'm using the wrong color there. I would go further backwards and change the pints back into cups. So it says 2 cups is 1 pint. So all of this, the quarts will cancel themselves out, the pints will cancel themselves out, and then we'll be left with cups.
I'm lost.
Give me 1 second, and I think the second method is going to be a little bit better for us. Okay. So in the numerator, we've got 1 times 2 times 2, which is 4. in the denominator. 2 times 1 is 2, times 1 is 2. 4 divided by 2 is 2. So that's 2 cups, 13 quarts, 2 cups. Actually, that is the final answer right there. Now, there's a different way to get the 2 cups, and that's, let's go back to this line right here, okay? So I'm gonna move this line over here so I can work with it. Remember back when we got 3 pints with this line right here, which I've just moved up here. What we know is that 2 pints is 1 quart. So what we could have done, and this, again, I don't know if this makes it easier. I think it does, though, is we could have said, remember that 1 quart is 2 pints. So if I take 2 pints away there, I would have 1 pint left over. But this 2 pints that I took away adds 1 extra quart. So over here, let's see, back over here, we could have added that 1 quart back here like this. And then all we've got to do is look at, see how many 1 pint is. Now that may take a conversion factor, but of course the conversion factor, it may take some dimensional analysis to change this 1 pint back into cups. But I know 1 pint is 2 cups, so that's where the 2 cups can come from as well. It's just a different way to look at it, but that's one way to do it. Here's what we're going to do, because that can be really confusing, and I understand that, is we're going to give ourselves an extra conversion factor down here. 1 quart is 4 cups. There you go. Now you're going to have to add that into your notes. You wouldn't have anything like this on an exam, but at least for the assignment, it should help us out. So with this extra conversion factor, let's go back. Remember, we're just looking at these 6 cups right here. So if you were to convert those 6 cups into quarts directly, now we're using this conversion factor here. So it would make that 6 over 1. Then would multiply it again. We want the cups to go away, so cups on the bottom, and then quarts on the top. This will convert it directly, 4 cups to 1 quart. And then this will change this. Again, how many quarts is that? Well, the cups are going to cancel away just like we want them to.
What about the 4?
So we'll change it into quarts. Yeah, so that's where the 4 and 6 come from. So 6 times 1 in the numerator is 6. In the denominator, 1 times 4 is 4. If you were to cross simplify the 6 and 4, I mean, which you can do, I don't know. I just don't know that it helps us that much. Now, the reason why I'm saying that too is because the denominator is 4 and it's 4 cups to 1 quart. And so right here, whether you wanted to look at this as 1.5 quarts, which we've already seen, or if you wanted to look at it as 1 and 2/4 quarts, again, the 1 quart is what we added, and then you'd have 2/4 of a quart, which is telling you how many cups are left over, which is what we've already seen. So the 2 is the cups, the 1 is the quarts. Or what you can do, I mean, if you didn't realize that, let's say you changed it into 1.5, then you're gonna have to change this 0.5 quarts back into cups with this conversion factor. Okay, now subtraction, right? 10 feet, 10 inches minus 8 feet, 11 inches. Let's see. Now, like I said before, I like to just stack and do this. And since these ones are just feet and inches, I'm just gonna give myself some space. It was 10 feet, 10 inches. And then it's minus the 8 feet, 11 inches. Now, of course, you noticed that 10 inches minus 11 inches puts us in the negative, which we can't do. So that means I'm going to need to do some borrowing with the 10 feet, 10 inches. So I'm going to do that. I'm going to take away 1 foot here, and I'm going to give it to the inches. Now, again, 1 foot is 12 inches. So that's going to change the problem at least just a little bit for us. So 10 feet minus 1 feet would be now 9 feet. But the inches now is 10 inches plus 12 inches, which is 22 inches. Now we can take away the 8 feet, 11 inches, because I now have enough inches to take away from the inches that we start with. So let's do that. We got 22 inches minus 11 inches, which would be 11 inches left over. Now 9 feet minus 8 feet would be 1 foot. And that's it. Yeah, so I know it ended up being 11 inches. They're not the same. This 11 inches is not the same as this one because it was subtracted. We just happen to have 11 inches. That's it. All right, try this one. Subtract 20 pounds, 9 ounces minus 19 pounds, 12 ounces. Let's take a look how this works. So again, I'll do some separation on this. We got 20 pounds and 9 ounces. So I'm just giving myself some separation there so I can work. And then we can subtract the 19 pounds and we'll subtract the 12 ounces. Okay. Now again, the subtraction here is problematic because with the ounces, the smaller units, I don't have enough ounces to start with to take away the 12. In other words, if I did this part right here, I would end up with the negatives, and I don't want that. So I'm going to take those, I have to borrow. My 9 ounces is with the 20 pounds, so I got to borrow from the 20 pounds, just 1 pound. I'm going to take 1 pound away, and I'm going to give it to the ounces. Now the ounces, the mistake that I made, obviously, was changing the ounces into inches, but remember, it's 16 ounces for the 1 pound that we're now giving to the ounces. So this will change the pounds and ounces. By taking one from the 20 pounds, we now have 19 pounds. And we added 16 ounces to the 9 ounces, which gives us now 25 ounces. So from there, we can take away 19 pounds. And we'll take away also the 12 ounces. So we'll start with the ounces. First, 25 minus 12 is going to be 13 ounces. And 19 pounds minus 19 pounds, what do you know, 0 pounds. Now I'm putting the 0 there on purpose because on the assignment, it's going to give you 2 boxes for pounds and ounces. And just so you know, you may have to put that 0 in on some of them. So, but of course, if it wasn't 0, you just keep that number there and put it in 2. So you have 2 gallons of gasoline in a container. You pour 1 gallon, 3 quarts into your riding lawnmower. How much gasoline do you have left in gallons and quarts? Gallons and quarts. So by pouring this in, that means we are going to be using subtraction here. So we're going to expect that. What it says is that we're going to start with the 2 gallons that are already in the container. That means that there's 2 gallons but 0 quarts. Now I'm going to keep those 0 quarts because, of course, we just poured out 1 gallon and 3 quarts. So that means we are going to be subtracting both. But again, I needed some kind of quarts to start with. There were just no quarts from the 2 gallons that were there. So we're going to pour out the 1 gallon.
1 gallon, which is 4 quarts, right?
We're going to subtract the 1 gallon, and then it was also 3 quarts that goes into the lawnmower. So yeah, the quarts is problematic because we don't have enough quarts to subtract 3 quarts from, right? Okay, so let's show the work on that then. So the gallons, of course, 2 gallons, 0 quarts. I'm going to take away 1 gallon, and that's gonna, I'm gonna give that the 4 quarts. Now, how do I know there's 4 quarts in 1 gallon? It comes from this conversion factor down here. So this is going to change this a little bit for us. Now it's, I took away 1 gallon from the 2 gallons, so I now have 1 gallon. And the quarts, 0 quarts plus 4 quarts would be, well, 4 quarts. And I probably didn't give myself a lot of space there, but remember the second part, we're taking away the 1 gallon and 3 quarts. So we're going to subtract these instead, and this will tell us how many gallons and quarts we have in the end. So in quarts, 4 minus 3 is 1 quart. And 1 gallon minus 1 gallon is 0 gallons. So just writing the answer bigger, of course, just 0 gallons and 1 quart. That's how much you'd have after putting a gallon and 3 quarts into the lawnmowers. Just this one. So there's our objective. Hopefully we feel pretty comfortable adding and subtracting with mixed units. Of course, they're the same types of units, right? Length, capacity, and weight. But hopefully we feel pretty comfortable doing that. Addition, of course, you'll do some carrying. With subtraction, you'll do some borrowing. But it's different than it is with just regular place value stuff.